Good afternoon. My name is Randy, and I'm here with my fellow Joshua. We'd like to present you the data modeling and processing on Travel Super App. So, eh, a bit about Traveloka. So our mission is we are trying to empower discovery. Means we'd like to enrich people's life by giving a possible opportunities to kind of like do some activities or attractions, going to new places, meeting new people. So this is where we kind of like have a vision at, and roughly in order to know what are our challenges, we'd like to explain our business first. So these are our businesses. So imagine if you are going from one city to another and you would like to, for example, book a flight ticket and book a hotel ticket. And there you might want to experience some new activities. So we provide all of them. And our challenges here is each of the business units actually have their own business flow. So if you would like to book a hotel, compared to when you book a flight, the form or the information that you need to provide to the app is kind of like different, right? Um, Even it's more different compared to, for example, roaming package. So each of the business have their own characteristic, and it's quite different from one to another. So that's the characteristic of the business that we have. Um, Yeah, a bit more about Traveloka. We are expanding to 6 countries now. Most of them are in Southeast Asia. We have 8 offices, including Singapore as well. So what are our challenges actually? There are 2 challenges that we'd like to share today in this occasion. The first one is data modeling silo, and the second one is dirty data. So what is a silo? As I explained before, Traveloka has several businesses or service or product, and each of the businesses has their own characteristic. And what we try to start in the beginning is we try to democratize data wrangling or data processing. Why we want to democratize that? It's just natural to democratize that because it means each of the business unit can be more agile to fit the business purpose, right? So that's what we did. However, they kind of like create their own data model, their own data that can support like insights or maybe machine learning pipelines. And what we have end up is in each of the business unit, the data model is actually quite different from one to another. And the most challenge with that different data model from one business unit to another is it's very hard to analyze data across business unit. So who's our most actually? When we have different data from one product to another, the biggest challenge is on those functions. So when we have a function that is actually across all products, they need to analyze data across business units, right? So when they need to analyze data from different business units, they need to kind of like make it uniform first in their side. And after they make it uniform, then they run their analysis. This is a very first, very exhaustive step, and second, it's also very expensive. And imagine if each of the business, the function also does the same. So it's a kind of like a problem. I put one business example here. Let's say we would like to know CLV or customer lifetime value. The simplest way to do it is just to kind of like sum all profit from the customer that we have. But since we have different sales data in each of the business units, it's very hard to do so. And how do we solve this data silo? We come up with some kind of like generic schema. So it's very natural. You have different data, then you would like to enforce some kind of like convention, right? So that's what we did. We kind of like designed a generic schema across the business unit. So this is how you need to comply with. Like for example, a simple example is if you have a sales data, then at least it has an order ID, date, time, etc. But then how? The next question is how you can ensure that that convention is being implemented in each of the product or services. There are 2 options actually that we have. First is, let's say we have a console of reviewer. So there are, for example, a group of reviewer that each of the business unit can propose their data model and then someone approve whether it's compliant to convention or not. But that's manual process and actually error prone. So we come up with a framework. So the framework that I'm talking about is a schema inheritance concept, where we have so this inheritance concept is actually a concept that is quite simple and applied in several domain, like for example in object-oriented programming. The concept is there is a parent, and the parent has its properties, and it has a child, and the child will inherit all properties from the parents, as simple as that. And the central team in this case will define the parent schema, and each of the business unit will be the child of that schema, and automatically will comply to the convention. This is one very simple example. We put one inheritance tree here. In the very up there, we'll have an all event schema. In this all event schema, the columns are any columns that has to exist in all event data in Traveloka. Let's take one simple example like event ID or timestamp that has to be there. The child of the L event schema is user behavior schema. In this user behavior schema, we'll have more information about our user, like user ID, the setting in their apps, like language, locale, something like that. And the child of the user behavior is each of the events. In this example, I put sales product schema, which is child of user behavior. The circle one in the diagram is schemas, and the rectangle one is the tables. So let's take one example, like in the flight sales table, we might the table will have the column from all event, user behavior, and sales. So it's kind of like try to enforce the convention based on the inheritance schema that we have here. And in this example, flight and hotel sales table will have common columns. For example, if in the sales product schema, maybe there will be revenue column or profit column, like that. So it's kind of like enforced, so it's uniform across the business unit. Yeah, this is just one real example. On the all event schema, user settings, and sales schema, what are the fields that are actually there, and it's kind of like inherited from its grandparent to the grandson. So a bit of a pick on the implementation. We use YAML. YAML is kind of like similar to JSON. It's just a way to express the schema. So if you see here, the parent on the flight search YAML in the bottom, it has a parent user behavior, and the user behavior is a parent at all event. And our framework is kind of like resolve recursively into the parent. So after we make the table uniform across all business unit, to answer the example question that I've put in the front is as simple as this. You can just select group by and from. Actually, I'm using a BigQuery dialect here. I think it should be similar in other database appliance. The stars there is union all tables with the same prefix. So when we union all tables from all the business unit, this is how we do that. Yeah, so that's about data model silo. And now the next one is about dirty data. And when we talk about dirty data, again, the problem statement that we have is each of the business unit have their own processing, right? And when we observe, there are many duplicated effort that has been done in each of the processing. And we see that dirty data is one of them. And when we check the pattern, most of the patterns actually most about business rule. Like maybe whether it's kind of like in the range of minimum, maximum, or whether the string pattern is something that is acceptable or expected or not. And what are the possible values? For example, if you have a status, the possible values should usually finite and view, right? There might be data that is kind of like outside that possible values. And it's a repeated process. I think that's clear. And now, how we fix the situation is, as I explained before, we have a kind of like schema to explain the parent-child relationship, right? So we put business rule there as well. We put business rule there. In this case, I put several examples. First is the parent there. It's actually regex. So if you have a version, and this is actually just semantic versioning pattern regex, you can check whether the data that is coming is actually comply to these regex patterns or not. Another example is maximum and minimum value of an integer and several possible values of our booking status. So imagine you don't have to implement those codes, and you can write once and use everywhere. And the most important thing, I think, is the concept of executable schema, where several roles in data team can collaborate together. So we don't have any other documentation than this. Description of data is there. Business rule is there. So data governor, analytics, business owner, everyone is kind of like collaborate in the same document. So the idea of this executable spec is actually quite interesting. So yeah, that's about the dirty data. We call this framework as NeoDDL. We are not good at naming, but yeah, it's kind of like just a new of a DDL, normal DDL. Think of create table comment. It's just a simple YAML. It supports inheritance, and we put some business rule there, and maybe some more features like default value. I haven't put it here, but actually it also integrated with our data catalog system. So the description that has been put in this schema will be sent to our data catalog and can be seen directly on the table description, and also searchable by the analysts and scientists. So yeah, now I think Joshua will explain more about the implementation details, so you get more traction. Thank you.
Okay, thank you, Randy. So now you already know what are the features and the usage of the NeoDDL. So now I'll talk about how is NeoDDL being utilized in our data processing flow currently. So it is currently being used in our data warehouse pipeline. I'll give you a brief overview on our data warehouse architecture. In a nutshell, you can see in the slides, it combines the multi-layered architecture with the data warehouse bus approach by Ralph Kimball, where each business unit has its own conform dimension or data mart, and together they form the bigger data warehouse. I will explain more on this on a later slide. Most of the data are collected and stored in the BigQuery, and each layer here, from L1 to L4, will have increasing data quality, and they also have different data granularity. You can see L1 and L2 can be considered as data staging area, where error discovery, data restructuring, or data masking are being performed. L3 and L4 is a model data area, where the data is modeled according to the common business process, for example, order, sales, or refund. So the only difference between L3 and L4 is that L4 is the aggregated version of L3. It can be aggregated based on time, for example, weekly, monthly, or yearly, or aggregated horizontally across business process to calculate, for example, conversion rate. Okay. So obviously, since DDL is in the name, NeoDDL is currently being used to define the schema and also to create all the tables in L2 and L4. Since we are following dimensional modeling described by Kimball, most of the tables that we have in L2 and L4 are either facts or dimensions. I'm not going to dig deeper on what facts or dimension is, but essentially facts are a collection of events that happens in our application, and the dimensions are the accompanying detail of that event. For example, a fact can be a flight sales booking, and the dimension can be a user or a device that have an attribute such as app version or device type. And what's interesting is, since we are using BigQuery, and BigQuery allows nested data structure, naturally we want to embed that dimension into the fact tables instead of having a separate dimension table. So this is where NeoDDL comes to shine. Using the inheritance feature that Randy has mentioned just now, it becomes much easier to define the embedded dimension structure that will be used for all business units. So one example, like Randy mentioned previously, we have a schema called user behavior. This user behavior actually contains some dimension. One of it is user dimension and also a device dimension. So if a business unit wants to have this dimension inside their fact table, what they need to do is just inherit those user behavior schema, and their fact table will automatically be embedded with this user dimension and device dimension. So it is, okay. Wait. So it ensures that all business units will have the same dimension structure. And this way, we get the increased performance from the nested data structure because we will have less joins. But we can also still enforce the dimension structure across business units. Another part where we use NeoDDL is during the cleansing job in data flow. So remember that what Randy said previously, in each field we can have a simple business rule validation. So each of these rules, plus some other validation specific to that business units, will be converted into individual step in the data flow job. By the way, data flow is just a managed version of Apache Beam from GCP. So in addition, not only that we have consistent structure, but all the business units can expect if they have the same dimension, same field name, that field will undergo the same business cleansing rule. So as you can see on the left, we have a sample of NeoDDL, and for each of the business rule, we'll convert it into individual step in the data flow job on the right. I'll explain to you some of the simple business rule that we do on data flow. First is just a simple casting. We'll try to cast the content, and then if it is castable to the specified type, we'll continue the validation. If not, we'll ignore that field, and we'll tag the record and provide the default value. You might think that, well, casting should be easy, right? And it should be enforced on, let's say, product side. But since some of our source might have a weak data type consistency for, let's say, some of our products are still using MongoDB, it has become a problem because when we ingest them, we are actually getting just a JSON string. And MongoDB doesn't really enforce the data type, so we are actually doing the enforcement on our data side. And also, why tag the data instead of removing the dirty record? Well, it is simply because different end user has different tolerance to the error. So the data flow job responsibility here is actually just on the error discovery. Some users might have low tolerance to error, or they might be just want to analyze that error records. So the error correction and mitigation will only happen on the subsequent layer, or as needed by the end user. Next is just the string validation. We have the min, max, and pattern. Quite obvious here. We'll do the error tagging and some simple string transformation, which is padding and truncation. We did this because we find this pattern across business units, and that's just a requirement that we have. Next is the numeric validation. This is just a min and max value. There's no data transformation will be done here, just error tagging. By the way, I will explain more about error tagging after this. Next is the enumeration, quite obvious. And the null check type. We will just see which field is declared as required, and if there's any null value, we'll give a default value on that field. So, what does error tagging looks like in our data warehouse? Basically, all of our tables in data warehouse has a column called DPE. DP is just an internal code name for our project, and E is error. It is basically a repeated field that contains 3 fields: error message, ETL name, and class. In the error message, you can see in the slides, it shows explanation of what rule has been violated and by which field. The ETL name shows which ETL catches this violation. And the class just show which Python class that is responsible for validating and producing the error message. So you can imagine that one record can have multiple violation inside, and we combine them together in these repeated fields. Okay, so on the top records, you can see that it is just a casting failure. The provider hotel ID just expect a number, but instead it has a string inside. And there's a lot of interesting stuff that can be found just by looking at this error message. As you can see in the middle, the payment method is null, which is unfortunate because this record might be a fraud, but not all is unfortunate, because if you see on the bottom example, we have a user payment status which is actually overpaid. So in this case, thank you, I guess. Yeah, by the way, this is what we retrieved directly from our booking table. And here are some more examples with error records. The top example is just a string format error where the ID expects minimum of three strings, and then we just do some simple data padding. And some more interesting findings that we found also in the error tagging is that we have a validation for each flight ticket booking. We need to have at least one adult. But what we found in some booking is actually we have 0 adults. So in this case, what a brave young soul. So we have some future plan that we think is going to be beneficial for our business side. First is to add more business metadata for data cataloging. If you see in the slides, this will be really beneficial if we know who are the business experts for that table. And for each column, we can also tag who is the column owner and the business expert. And not just inside the table, but we are also trying to add a metadata on a data model relationship. So for example, we can tag a field as a foreign key, and we can define what is the target table for that foreign key. It can enable us to automatically generate a star schema diagram, like you see on the right. The flight search is of fact tables, and the category, suppliers, and order details are the dimensions. They can be from another tables, but they can also be embedded inside the fact tables itself. So the ability to create automatic star schema diagram will be really useful for the engineers as well. So thank you. That's all. And any questions?
Hello. Yeah, hi. So my question is that you said that you will be expanding in more countries in recent future. So this is kind of a centralized database where you bring all the businesses together. So as you expand to new countries, you will have more dirty data, right? And which will require more collaboration. And the matureness of the business might not be the same as older countries from day one. So in that case, how do you think, what are the kind of challenges you will face and how will you solve them?
So yeah, this is actually quite interesting. In some cases, it's more about string format. Like maybe in some countries they're using the alphabet, right? We sometimes there are problems there. However, when we expanding to new countries, actually the pattern is not that different. It's merely about adding new value in the dimension, and the differences of the data is not that much because it's kind of like a very similar business, just new country. I think the only thing that we found so far when expanding to 6 countries just difference in the field value, especially the text.
Okay, just a follow-up question.
Sure,
Say, for
sure.
example, you're expanding to a new country which has a new currency. So all your revenue numbers will be reported in a new currency now. So then how do you manage updating each and every time? And when would you know when to update your patterns and checks? In the
Yeah, for that part, actually, we kind of like convert everything to USD. So yeah, so it's not in each of the currency, it's kind of like all converted to USD. So yeah.
Thank you.
Thank you.
Good talk, thank you. I can see how the NeoDDL is going to work with event type data. Are you using a similar tool or the same tool for like your slower moving data from databases as well? Like, are you duplicating the schema to some extent from Postgres or MySQL or whatever to your YAML definition?
Yeah, yeah. So the answer is it's depends. So it has several variants in our observations. In some cases, in the ends, the data that is coming from the mutable data is actually we transfer it into something immutable. Like for example, there are order data and the order is kind of like changing from one status to another. We kind of capture the status changes and make it event. So in this case, it becomes similar. However, there are some cases as well where it's more makes sense to kind of have glossary instead of inheritance. For example, if you'd like to enforce one single term is being used across the company and there is no ambiguity on that. So actually, we also have developed something that's similar to that. Internally, we called it Mixin. It's kind of like a business glossary for a business. But yeah, I think that's we can discuss that more later. But in the end, what we do is when we take data from databases, we try to extract the event because we'd like to put it on the fact table, right? So it's need to be immutable. So that's what we do. Oh, yeah, I think yeah. Thank you.